Reflection is a language feature provided by some languages. So here I have an example of C# and Java. And what reflection lets you do is kind of like looking in a mirror of a type. But reflection is missing from C++, and it's been missing for a long time. Unreal has built its own reflection system. And so the reflection system and the engine seems to rely on these like reflected types. So there's like UClass, UScriptStruct, and UEnum. And there's a lot more. So all of those inherit from public U field. And you can see all the different types of reflection types in the engine. And just to make that clear, a lot of these are inheriting from the U field. So we have UClass and UScriptStruct, which are both UStructs, and the UStruct is a U field. And UEnum is its own thing. It's just an inherited from U field. And so the first thing is for UClasses. So here's UClass. There are two related things. So if you look into the code, you'll find that there's this function called GetClass. There's also a StaticClass. And they return this UClass pointer. So this is its own type, and this UClass effectively seems to represent the reflected properties for a given class. And so the GetClass gives you the most derived thing. So if a blueprint is inheriting this type, this will give you the blueprint, as you can see there. The StaticClass gives you specifically the thing associated with that type. So ignoring the whatever the current object is, just get the static reflected class here. But generally, you probably want the GetClass method to give you the derived most class. And so you can see here, I have this class and I have various properties. I have functions on it. And here we can ask the class, the UClass, to find a property by its name. And I just have a string for this name, myFootProperty, which is right here. And same thing for my blueprint callable, find function by name. This is the name. You can see my blueprint callable function is right there. And it's able to return these reflected types like fProperty or ufunction. And just so you know, you don't have to like type a string every time. There is a macro to help you do this type of thing called getMemberNameChecked, which is kind of a compile time check to make sure it actually exists, that property on this type. And same thing for function. Get function name checked and get member name checked. And so we have this ability to kind of request a UClass to get reflected data about a given class. And this is actually extremely useful for other things that actually are gameplay. So for example, if you wanted to spawn an actor in the world spawn actor, say we want to duplicate. We can get the derived most class like this, GetClass, and we can spawn another one somewhere in the world using the world spawn actor. And so this is able to take this UClass, the reflected class, and somehow translate and instantiate this C++ class. And so this thing is a blueprint class. So we're able to do this without ever writing code that exposes this blueprint type to C++. So this is a really powerful feature. It's perhaps a little subtle in understanding it. And then there's other features that are useful from this reflected thing. So you can get this superclass, which can be used in various ways. And the more you look at this, you start to see that it's pretty widespread, the use of reflection in the engine. For example, here I have a data asset, and this data asset spawns an actor class. And you've probably seen TSubclassOf, and you specify the type, and then in the editor, you pick the blueprint subclass you want. And then in the world, we can pass that TSubclassOf to spawn actor, and it's able to do it just like we did with the other one with UClass. And the reason this seems to work, if you look deeper into it, under the hood, it's the same thing as just providing a UClass. TSubclassOf has a property called class, which is of type UClass. And so this is some examples of reflection being used in regular gameplay as far as the engine is concerned. Since we're on the topic of UClass, I feel like it's worth mentioning the ClassDefaultObject, or CDO. CDO is effectively like a singleton that has all the default values on it. So there's a couple ways to get defaults. The thing you should look at is getting the UClass. So here we have GetClass, the derived UClass, and then on the UClass, you ask it for the default object of that type, and it gives you back a casted version of that default object. And that default object can be used to restore state. So in this case, I have a float property, default is 5. On this level instance, I've set it to 123. And here I have a function called readCDO that effectively wants to restore it at runtime. So what it does is it requests the CDO, and then it reads the CDO's version of this, which is going to be 5, and it puts that 5 into the instances variable here, and then I log it, and we can see down here it changed from 123 to 5. So that's what a CDO is. It's effectively like a singleton object that has the default values. And there is another getDefault, which is this here, and this is more typed to this specific class. It won't give you the blueprint ClassDefaultObject. You can see the names here. This is the blueprint reflection tester, and this one is the default UHT my reflection tests. And if you look at these functions, you can see why there's two getDefaults. One of them provides a class, the one that gives you the static class effectively, or this right here, the one that gives you the default that is this type and not the derived type. That one uses the static class, and that's why not the current class. This other one that takes a UClass just calls the class GetDefaultObject. And so that's why there's a difference. Be aware of that when trying to get a CDO, that make sure you call the right function for what you need. So we have this ability to kind of request a UClass to get reflected data about a given class. If we look at a ustruct, here I have one defined. We can do something like UClass, but it's the static struct for this struct. And it returns this scriptStruct pointer, which is effectively a reflected type. The same is true for enum. So here's an enum that has two values, first value, second value. And there's this static enum function we can call to get a UEnum pointer, which seems to be a reflected enum. So I hope it helps, and until next time.